I am Mr. Ish and I am welcoming you to this video. Eliminate the parameter. Extra practice on this specific technique. We have two parametric equations represented, three variables in total, x, t, and y. We have to eliminate the parameter and develop a rectangular equation. When you're looking here at x is equal to t plus 2, you can solve for t and make it x minus 2. This x minus 2 will substitute for the place of t over here. You'll have x minus 2 whole square. You know, when you're looking at that, you are looking at a parabola. It would have a vertex. Vertex here would be 2, 0, 1, 2 right over here. We don't have to be very accurate with the depiction. Let's refrain from drawing these arrowheads because we have to determine the direction of this. You could actually make this into a 0 and you'll have a y-intercept here of 0, 4 because you'll have a minus 2 square. So these are the points 2, 0 and 0, 4. How can you determine the direction of this curve? Well, again, look at this in terms of increasing t values. Come up with some good values because you're looking at everything here with regards to a parabola which has a minus infinity to infinity domain. You can pick up some values. How about we just look at values such as minus 1, 0, and 1. When you put minus 1, 0, and 1, you're looking at in this equation right over here. When t is a minus 1, x is equal to a 1. When t is a 0, x is equal to a 2. When t is a 1, x is equal to 3. Now you take these 1, 2, 3 values and you plug them right here and solve for y. When x is a 1, you're getting a minus 1 square, which is a 1. When x is a 2, you're getting a 0 square. Here it's a 0. When x is a 3, you're getting a 1. Now look at this. In the trend of an increasing t, minus 1, 0, 1, we're getting 1, 2, and 3, but we're getting 1, 0, 1. As the t values are increasing, the x-axis values are increasing, and the y value goes from up to down to up again, and that tells you that the direction of this parameter will be exactly like this. You have a curve which is going in this direction right here. Just for extra clarity, it's going like this. And you can see that from the trend of these values over here. So this first question here has been completed. We can look at another one now. How about this one? We have x is equal to e to the power of minus t, y equals e to the power of 2t. These are parametric equations. You can start from here and solve for the t. You'll have natural log x is equal to minus t natural log e, which is 1. T here is equal to minus natural log x. This here can substitute for right over here. Y is equal to e, and you see this minus here, we can bring it right here with the minus 2, and you'll have a natural log x. That right there is a very interesting property of logs. You know, e to the ln x is always equal to, anything which is e to the ln x is always equal to x. E to the minus ln x is always equal to 1 over x. Think about these in terms of the properties you know of logs, and you're looking at something like this. How about we look at it like this? Y equals 1 over e to the 2 ln x. Now that looks very much like what you're seeing right over here. Also, look at this fact right here. A ln x is equal to ln x to the power of a. Here I have a which is 2. It can come over here. This is equal to 1 over e to the ln x square. When I'm looking at all of this in terms of this, what I'm seeing over here, I can bring that into play. Y is equal to 1 over x square, and that right there is your rectangular equation. The parameter has been eliminated and a rectangular equation has been developed by the aid of these properties over here. Now let's look at a graph over here. Y is equal to 1 over x square. Y is equal to 1 over x square. We're looking at everything which would look like this in terms of a graph. But since we had natural logs over here, we could even say for those values x is greater than 0, and we can then just focus only on the side you see over here. You see how we're looking at just this? For assuming the value is greater than 0, we're looking at that. When we're looking at this right here, now we have to determine the direction of this curve, and you can do that. Anyhow, this right here is my rectangular equation. Let's do a value t, x, and y. And let's come up with some values, because we have an exponential functions here. We can do these type of values. When you put minus 1 over here, you're looking at e to the power of 1, and x is equal to e. When you're putting 0 over here, e to the power of 0, x is equal to 1. When you're putting 1 over here, you're looking here at 1 over e, because x is equal to e to the power of minus 1, which is 1 over e. Now take these x-axis values and plug them right over here. When you're looking at x-axis value here of e, you're looking here at 1 over e square. When you're looking here at a 1 in terms of x, y becomes a 1. and 1 over e becomes an e squared. Think about it. You'll have a 1 over e squared, and that will flip up to e squared. That's exactly what we see. So those values allow us to determine the direction of this graph. You're always looking at everything here with regards to increasing t values. As the t values are increasing, I'm seeing, what am I seeing over here? I'm seeing an inverse effect in terms of x. As the t values get larger, the x-axis values get smaller and the y values get larger. I'm seeing a direction which develops in this way right here. So the curve is going in this direction, and allow me to show you like this. Curve is going in that direction right there, and that would be the direction you would determine from the table of values over there. So this question here has been completed. Let's just look at one more, and that should be the end of this specific video. Let's look at this specific question here as our last one. X equals t squared, y is equal to 2 natural log t. These are two parametric equations. We eliminate the parameter and develop a rectangular equation. When you're looking here, you can do t is equal to x to the 1 over 2, which is the same thing as root of x. So that part is done. Now substitute it over here. Y is equal to 2 natural log of x to the power of 1 over 2. Now a good thing over here to remember is when you're looking at a ln x, it's the same thing as doing ln x to the power of a. This specific property comes in handy. Another property that comes very much in handy over here is basically a to the m to the power of n is equal to a to the mn, a property of exponents, because you're seeing this can migrate right over here. Y is equal to ln x to the 1 over 2 to the power of 2. You can open that up. You're looking at ln x to the 1 over 2 times 2, and you have y over here is equal to natural log x. So this right here represents the rectangular equation which develops as these parameters are eliminated. Now what remains is developing the graph and determining the direction. You know the graph of natural log x is not hard. It has a standard point right here, 1, 0 x-intercept. It looks something like this, but we have to determine the direction of this parameter. We can do that. We can do t, x, and y, and we can bring in three values. Since we're looking here at natural log, let's keep everything in the domain of a natural log. How about 1 over 2, 1 and 2 in terms of the x values? When you do 1 over 2, 1 and 2, you do right here. 1 over 2 square, 1 over 4. 1 square, that's a 1. 2 square, that's a 4. Now put these values right here in this natural log. Natural log 1 over 4. You know the natural log of those values which are less than 1, greater than 0, and they're always negative. So you'll here have a negative answer right here. Natural log 1 over 4 will be minus, but natural log of this 1 in terms of x value is a 0. Natural log 4, well, that's a positive value, natural log 4. Now you know you have to determine the direction of the curve with regards to increasing t values. As these t values are increasing, the x values are increasing, and the y values are increasing. You're going from a minus 0 to a natural log 4. So the direction of your curve is that in this direction is exactly what develops and what appears here with the analysis from that table. So in this video we presented you three questions. We eliminated the parameter. This was all practice here, and then we developed the rectangular equation. We graphed that equation, the rectangular equation, and then we determined the direction of the curve, all of which will be making more sense as you get into higher level calculus. Here you're just learning the technique, you're learning the how and all of that, but you're not learning the why right now. We'll learn the why part later on. We're here only focusing on the how. How is it that you do it? Later on we'll focus on the why it is that you're doing this. But that's it for this video. Thank you. You all have a great day. Bye.